Hi there, welcome back to another video. Again, we're doing another Instagram request, and this time it was requested for me to talk about the trigonometric graphs. So, to me this means sine, cosine and tangent, but perhaps in a later video we will look at the reciprocal graphs, sec, cosec and cotangent. Okay, so first we need to recall what these sine, cosine and tangent actually mean. So in any right angled triangle where we've got one angle 90 degrees, we have these ratios. So sine of the angle is equal to the opposite side over the hypotenuse. Cosine of the angle is equal to the adjacent over the hypotenuse, and tangent of the angle is equal to the opposite over the adjacent. Now you might know these as the SOHCAHTOA relations. Okay, so hopefully you've learnt them. Right, but I don't want to be one of these guys who just says, here's the trig graphs, you need to learn them, or just memorize them. I want you to actually understand what's going on. So, in order to do this, we need to look at the unit circle, and that's this diagram I've got here. Right, so what do we have? It's a circle of radius 1, so that's what unit circle means. And we've put a right angle triangle inside it. So the hypotenuse is 1. So h is 1, that's the hypotenuse, because it's just the radius and it touches the edge of the circle. And now let's have a look at what sine theta, cosine theta and tangent theta are. Well, sine theta is opposite over hypotenuse, which is 1. Cosine is adjacent over hypotenuse. Again, hypotenuse is 1. And tan is opposite over adjacent. If we know that sine theta is opposite over 1, then this must mean that the opposite is sine theta. And I should stress that this isn't a 0, it's the opposite. If we know that cosine theta is adjacent over 1, then we can say that A, the adjacent, is cosine theta. So what does this look like on our graph? Well, this means we have this side here being cosine theta, and this side here being sine theta. Okay, great. And finally, if O and A are sine and cosine, then tan theta equals sine theta over cos theta. Right. Now, what I wanted to talk about in this video is, as we move this point P around the circle anti-clockwise, so this way, the radius is going to stay the same, but the angle is going to change. So, as we move P around the circle, and I'll put this way to mean anti-clockwise, theta changes, and therefore so do sine, cosine, and tangent. But the hypotenuse stays the same. So hopefully you can see what's happening. So say if this angle was 30 degrees, we'd know how to calculate sine theta because we just measure from P down to the x-axis and so on. Right, so hopefully that makes sense with what's going on. I will put a video link in the description which goes into this in a little bit more detail from exam solutions, and I will link an animation on a website which shows what's going on as well. So maybe I'll just write that link in description. But basically, as P moves around, the point moves around, the angle changes, and so do sine and cosine. And we can create a little table of values and then graph them. So let's move on to graphing them. Right, so hopefully you followed what was going on in the previous part. We're going to start with sine and cosine and go from there. So using the unit circle method, we can see that at 90 degrees, the value of sine is 1, which we'll put up here, and we'll put a -1 down here. Sine and cosine range between 1 and -1. That's just a basic property. Okay, when we get to 180, the value of sine is 0. When we get to 270 degrees, the value of sine is -1. And when we get to 360, the value is 0. Finally, the value when x is 0 is 0. Okay, so the graph looks something like this, hopefully if I can draw it correctly. Right, so that's y equals sine x. Notice it has zeros at 180, 360. And in fact, this graph repeats. So, repeats every 360. And I should point out that this is all in degrees. So, 90 degrees, 180, and so on. Right, cosine. Again, cosine ranges between 1 and -1. At 0, the value of cosine is 1, so that's up here. At 90, the value of cosine is 0. At 180, the value of cosine x is -1. At 270, it's 0 again. And at 360, right at the end, goes back up to 1. So the graph looks something like this. So hopefully that makes sense there. So let's have a look at the zeros of cosine x. So zeros, by zeros we mean where is the graph 0. So zeros at 90 degrees, 270. Again, this graph repeats every 360 degrees. Okay, let's move on to tan, the final one. Okay, here we are then with the final trig graph. So remember that tan x is sine x over cos x. So this does a couple of things. Firstly, we've got to be really careful that cos x is not 0, because if cos x is 0, then we're going to be dividing by 0, and all sorts of crazy things are going to happen when that happens. So let's have a look when cos is 0. So hopefully you remember from before, or you can just rewind and see that cos is 0 at 90 and 270. This means there are asymptotes at these values. So what does an asymptote mean? Well, it usually means that the function is undefined at that point. So again, because we can't divide by 0, this means we can't have any value of tan at these points. Right, and again, using the unit circle, we see that the tan graph looks something like this. So it starts off at 0, and it goes up, and it gets very close to this asymptote, but it never actually touches it. So the range of tan is actually not between -1 and 1, it's actually between -infinity and infinity. So the next part, it starts off down at -infinity, or very close to it, crosses through 180 at 0, and goes all the way up to +infinity. And the final little branch is here. So it starts down at -infinity and goes up to 0. So the zeros of tan are actually the same as the zeros of sine. So zeros at 180 and 360, and in fact 0. Okay, so hopefully this little introduction to the trig graphs makes sense. If you have any more questions and you'd like to see me go into how we use the unit circle in greater detail, then I'll be happy to do that. As usual, if there's any comments or questions, then let me know. Thank you very much for watching.